dear students, today the topic of the class is wrapping effect, bilinear transformation used for the design of IIR filter and how it can be avoided. In the previous class we have seen what is wrapping effect, what is the effect of magnitude response and phase response of wrapping effect on the digital filter. In this class we will be seeing how to avoid the wrapping effect, which is a drawback of the bilinear transformation method. So, bilinear transformation method is used for the design of IIR filter. It is an indirect method of designing an IIR filter because first we have to design the transfer function of an analog filter HA of S and then change it to H of Z using bilinear transformation method. What is the equation of transformation? S is equal to 2 by T 1 minus Z inverse by 1 plus Z inverse. Okay. So, bilinear transformation advantage is it is 1-to-1 mapping, that is aliasing effect is not there. The disadvantage of bilinear transformation method is wrapping effect and it can be avoided by using pre-wrapping. So, what is wrapping effect? It is caused due to the equation ohm is equal to 2 by T tan omega by 2. Ohm is frequency variable in analog filter and omega is the frequency variable in the digital filter. At high frequency, this is the equation. At low frequency, this tan theta, if this theta value is small, it leads to theta. So, this tan omega by 2 at low values becomes omega by 2 at low values of omega. So, which is written as omega by 2, 2 get cancelled. So, we will get the equation omega is equal to ohm t. This equation we have already derived in the previous class. So, at high frequency ohm is equal to 2 by T tan omega by 2, at low frequency omega is equal to ohm t. So, for low frequencies, the relationship between ohm and omega are linear. At low frequencies, the relation between ohm and omega are linear. But coming to high frequencies, the relation between ohm and omega is non-linear due to arc tangent function tan omega by 2. Third point, the influence of wrapping effect on amplitude response. We have seen in the previous class with the help of diagram also with the graph. What is the influence of wrapping effect on amplitude response? We have considered an analog filter with number of pass bands centered at regular intervals. Yes or no? How the derived digital filter will have? It will have same number of pass bands, but the centered frequencies and bandwidth of higher frequency pass bands will tend to reduce disproportionately. Okay, na? So, what will happen? The analog filter magnitude response number of pass bands will be same in the derived digital filter magnitude response, but the width will be disproportionate in the derived digital filter. Next, what is the influence of wrapping effect on phase response? Okay, this also we have seen in the previous class. So, if you give a linear phase response of analog filter and trying to transform it using bilinear transformation, the derived digital filter phase response will be non-linear. Okay, na? So, what will happen? The wrapping effect will give non-linear phase response. So, how it can be avoided? The wrapping effect can be eliminated by pre-wrapping the analog filter. This can be done by pre-wrapping the analog frequencies. That is, before transforming, we have to find what is a pre-wrapping analog frequency. Ohm p, that is a pass band analog frequency, and ohm as that is a pre-wrapping analog frequency at the stop band. Ohm P is equal to 2 by T tan omega P by 2, ohm S is equal to 2 by T tan omega S by 2. So, before transforming you have to find these two pre-wrapping analog frequencies and then apply the bilinear transformation technique. Okay. So, what is the wrapping effect? The wrapping effect is a drawback in bilinear transformation method for while designing an IIR filter. The influence of wrapping effect is clearly seen on amplitude and phase response of the derived digital filter. By the help of the graphs you can explain it, which we have already seen in the previous class. This is the magnitude plot. Coming to the, if you are considering an analog filter of linear phase, it is giving a non-linear derived digital filter. Okay. So, the magnitude response and phase response distortion is seen due to wrapping effect, and it can be eliminated by pre-wrapping the analog frequencies. So, at low frequencies there is no problem because ohm and omega are linear. Coming to high frequencies, the magnitude and phase responses are getting distorted. Thank you. I hope you have understood the class. If you have any queries, post in the comments. Good luck students. Thank you.